Imagine a cosmic shortcut that could whisk you across the universe in the blink of an eye. It sounds like science fiction, right? Well, welcome to the mind-bending world of wormholes, one of the most fascinating predictions of Einstein's theory of relativity. Picture this. You're standing on one side of the galaxy, and your destination is billions of light years away. Normally, even at the speed of light, this journey would take eons. But what if you could fold space itself, creating a tunnel that connects these two distant points? That's the basic idea behind a wormhole. And it's not just the stuff of sci-fi dreams. It is a concept rooted in some serious physics. Let's break it down with a simple analogy. Imagine space-time as a giant sheet of paper. Usually to get from one corner to another, you'd have to travel across the entire sheet. It's like moving through space the long way. But here's where it gets interesting. If you could fold that paper so the two corners touch, suddenly you've created a shortcut. A wormhole is essentially that fold in space-time, a cosmic tunnel connecting distant regions of the universe. Now, you might be thinking, this sounds too good to be true, and you'd be right to be skeptical. While wormholes are mathematically possible according to Einstein's equations, they come with some major catches. The biggest problem? Stability. If wormholes exist naturally, they'd be incredibly unstable. The moment you tried to send anything through, be it a spaceship, a signal, or even a single particle, the wormhole would collapse faster than you could say, "Beam me up." But don't lose hope just yet. Physicists have theorized a potential solution to keep wormholes open. Exotic matter. This isn't your everyday stuff. We're talking about matter with negative energy density. It's the cosmic equivalent of anti-gravity, pushing outward instead of pulling inward. With enough exotic matter, a wormhole could, in theory, be held open long enough for something to pass through. Here's where things get even wilder. If wormholes are possible, they might not just be shortcuts through space. They could also be shortcuts through time. That's right, we're venturing into time travel territory. Imagine a wormhole with one end in 2023 and the other in 2123. Step through, and you've just traveled a century into the future. Or what about a loop, where both ends are in the same place but separated by time? You could potentially meet a younger or older version of yourself. Of course, this raises all sorts of paradoxes and mind-bending questions. What happens if you go back in time and prevent your own birth? Could you change the past, or would the universe somehow conspire to preserve the timeline? These are the kinds of puzzles that keep physicists and philosophers up at night. But before you start planning your time-hopping vacation, there's a big caveat. We have absolutely no evidence that wormholes actually exist. We've never observed one, and we certainly don't know how to create one. The amount of energy required to form a wormhole would be astronomical. We're talking about bending the very fabric of space-time? It's not something you can whip up in a laboratory. So why do scientists still talk about wormholes? Because they represent a bridge between what we know and what we dream might be possible. They push the boundaries of our understanding of the universe and force us to grapple with mind-bending concepts. Even if we never find a real wormhole, studying them helps us refine our theories about space, time, and gravity. Wormholes also serve as a powerful tool for thought experiments. They allow us to explore the limits of our physical theories and imagine what might be possible if we could manipulate space-time itself. This kind of speculative thinking has often led to real breakthroughs in science and technology. Plus, let's face it, wormholes are just plain cool. They capture our imagination and inspire us to look at the universe in new ways. They remind us that reality is often stranger and more wonderful than we can imagine. From Star Trek to Interstellar, wormholes have become a staple of science fiction, allowing writers and filmmakers to tell stories that span vast distances and timescales. But it's important to remember that while wormholes are mathematically possible, they remain firmly in the realm of theoretical physics. We're not likely to be zipping between galaxies or hopping through time anytime soon. The energy requirements are staggering, the technical challenges are immense, and the potential dangers are hard to overstate. Still, the study of wormholes continues to yield fascinating insights into the nature of space, time, and gravity. Who knows? Maybe someday we'll discover a way to create stable wormholes, revolutionizing space travel and our understanding of the universe. Or perhaps we'll find that they're truly impossible, leading us to new theories that explain why. Either way, wormholes serve as a reminder of how much we still have to learn about the cosmos. They challenge us to think big, to question our assumptions, and to keep pushing the boundaries of what we think is possible. So the next time you look up at the night sky, remember that between those twinkling stars might lie hidden tunnels through space and time. We may never find them, but the mere possibility of their existence expands our cosmic horizons and fuels our sense of wonder. In the end, wormholes stand as a testament to the power of human curiosity and imagination. They represent the cutting edge of theoretical physics, where the lines between science fact and science fiction blur. Whether they turn out to be real or remain forever in the realm of mathematical possibility, wormholes will continue to captivate us, inspiring new generations of scientists, dreamers, and explorers to look at the universe with fresh eyes. So while we can't hop into a wormhole for a quick trip across the galaxy just yet, we can certainly enjoy the journey of discovery that the concept has taken us on. Who knows what other mind-bending ideas are waiting to be uncovered in the vast expanse of space-time? The universe is full of mysteries, and wormholes are just one fascinating piece of the cosmic puzzle. Remember, in the grand tapestry of the cosmos, wormholes represent not just a potential shortcut through space-time, but a shortcut to expanding our understanding of reality itself. They challenge us to think beyond the familiar, to question our assumptions, and to dream big about what might be possible. So the next time someone asks you about wormholes, you can tell them, it's not magic, it's not science fiction, it's physics at its most mind-bending and awe-inspiring. And who knows, maybe someday we'll find a way to turn these theoretical tunnels into cosmic highways, opening up the universe in ways we can barely imagine today. Until then, we'll keep exploring, keep questioning, and keep marveling at the incredible possibilities that lie hidden in the equations of our universe.
Stay curious.